Okay, in this video, we're going to talk about section F of chapter 1 of Baronett's logic textbook. Now, the main point of this section is to distinguish between two ways in which we can analyze an argument. First of all, we can analyze whether or not the statements in the argument are true or false. That's called truth analysis. But actually, even before we do a truth analysis of an argument, we want to do a logical analysis. And the logical analysis has to do with the relationship between the premises and the conclusion, regardless of whether those statements are true or false. Now, when it comes to deductive arguments, which is what we're mainly dealing with, then the logic of the structure of the argument is a matter of validity. Either the argument is valid or it's invalid. If it's valid, what that means is that the premises necessitate the truth of the conclusion. Let me put that another way. If the premises are true, or if they were true, it would be impossible for the conclusion to turn out false. Now, in a valid argument, the premises might not actually be true, and yet it could still be a valid argument. So analyzing the logic of the argument is different from analyzing the truth of the claims. So after we've determined whether a deductive argument is valid or not, then we want to ask, well, are the premises in fact true? If they are true, then that argument is a sound argument. Soundness requires both logical validity and the truth of the premises. But if the argument is not valid, or if it is valid, but at least one premise is false, then it is unsound. So when you're looking at a deductive argument, here's kind of your decision tree. First, you ask, do the premises actually necessitate the truth of the conclusion? If the answer is yes, they do, then it's a valid argument. So we're on this branch of the tree over here. But then we're going to ask the second question, are all the premises true? And if the answer is yes, they are, then the argument is sound, A+. If the answer is, well, at least one of them is false, then it's unsound. Now, on the other hand, if we've gone back to the beginning and we determined, you know what, those premises don't even necessitate that the conclusion be true. Do not pass go, do not collect $200. That's a reference from Monopoly, by the way, if you've ever played Monopoly. The argument is invalid, and it's therefore unsound. Okay, so you got four possible ways that you can evaluate a deductive argument. If you've got an argument whose premises are true and the conclusion is true, let's see. Let me back up here. This is basically a chart form of determining the decision tree. So I'm not going to walk through the whole chart. You can do that on your own. Now, it really helps us to identify the logical structure and hence the validity of an argument if we take a natural language statement, a set of natural language statements that are in an argument, and we reduce them to their mere form, their statement forms. Let me give you an example of what I mean. When we do this, we're going to take all the class terms in a statement, and we're going to substitute them with capital letters. So if I've got the natural language sentence, all Android phones are popular products. What I could do, the class terms here are Android phones and popular products. And I'm just going to say, let's plug in A for all Android phones and P for popular products. So the statement form of this sentence is all A are P. Now, why would you want to do a thing like that? Why would you want to gut out all the particular content of that sentence? Because it strips away the distractions and just gives you the bare bones structure of it. And this will help you to determine whether an argument is valid. Because what you can do is you can reduce all the statements of a natural language argument to their statement forms. Okay, so let's say we had this argument. All beagles are dogs, all dogs are mammals, and therefore all beagles are mammals. Okay. Let's plug in B for beagles, D for dogs, and M for mammals. The bare skeleton the argument form, the logical structure of this argument is all B are D, all D are M, therefore all B are M. Now this happens to be a valid argument. But what's true of a valid argument is that any argument that had the same form, no matter what it was about, beagles, dogs, and mammals, or any other three class terms, if the argument has this form, then it's going to be a valid argument. Okay. Now, this leads us to another move that we can make, which your textbook tells us about. We can develop substitution instances for arguments. In other words, once we've reduced an argument to this form, we can then plug in a set of three other class terms. Okay, so we, instead of beagles, dogs, and mammals, we can say, hey, let's plug in like men, women, and humans, or snakes, mountains, and rain. I don't know what, it doesn't matter. And why would you want to do a thing like this? Why would you want to do this? Well, it actually provides us a way to test for the validity of that argument form. Because if you can come up with a set of class terms that plug into that argument form, and that those class terms make all the premises turn out true, but make the conclusion turn out false, what you've done is you've proven that that argument form isn't actually valid. Because if it's a valid argument form, it won't be possible to make the premises turn out true and yet the conclusion be false. Because the truth of the premises, by definition, will necessitate the truth of the conclusion. Let me give you an example of what I mean. So here is another argument form, right? All B are S, all G are S, all B are G. Okay, now we could come up with a substitution instance for this argument. Let's make B stand for men. Let's make S stand for human beings. Let's let G stand for humans. Well, if you plug those substitution instances in, here's what you get. All men are human beings. Is that true? Yes, it is. All women are human beings. Is that true? Yes, it is. Therefore, all men are women. Is that true? No, it's not. It's false. So what we've given is a counterexample to the validity of this argument form. Any argument that has this form is not valid. And what we've done here is given a counterexample that shows that. It's possible to make an argument with this form, have all true premises and a false conclusion. The premises don't necessitate the truth of the conclusion. All right. Now, just when you think you're getting your head around this, let me ratchet this up a little bit. So far, we've been working with categorical logic. We took class terms that denote a category of kinds of things, like say men, and we plugged in a letter for them. So in categorical logic, the basic units that you're working with are class terms: dogs, pizza toppings, men, women, whatever you want. In propositional logic, the basic units are statements. So not just a single class term, but say a statement like pizza is delicious. It's a complete sentence. It's true or false. And these statements can be simple statements or compound statements. Simple statements are not composed of any simpler statements. Like pizza is delicious, as an example. Compound statements are composed of simpler statements that are joined together by logical connectives. So for example, if I say pizza is delicious and I eat it every Friday, that's a compound statement. It's got two simple statements: pizza is delicious and I eat it every Friday. They've all got subject and verb, and they're joined together by and, which is a logical connective. Or take this conditional statement: if today is Friday, then I'm eating pizza. So simple statement: today's Friday, I'm eating pizza, joined together by the conditional if-then structure. So we've got simple and compound statements. Now the point of all this is as follows. If you want to come up with an argument form, using propositional logic, then you're going to substitute a capital letter for each of the simple statements that are involved. So, for example, we got this one. If Sherry lives in LA, then she lives in California. If Sherry does live in California, therefore she lives in LA. So if I'm going to do to boil it down to the argument form, then I'm going to make L stand for Sherry lives in LA. I'm going to make C stands for Sherry lives in California. So if I plug in those letters in place of each occurrence of those statements, here's what I get. If L, then C. C, therefore L. Now, by the way, this is not a valid argument. And boiling it down to the structure like this, to the mere argument form, helps us to make it clear, because I can come up with a counterexample, a substitution instance in which the premises could be true and yet the conclusion turn out false. For example, let's plug in here, let's make L stand for it's raining. And let's make C stand for the streets are wet. Now, if we plug in those substitutions, here's what we get for this argument form. If it's raining, then the streets are wet. That's true, let's say. The streets are wet, and maybe that is true. Does that necessarily imply, though, that it's raining? Not necessarily. Maybe it's a sunny day, no rain, and somebody hosed down the streets. So what I've come up with here is a substitution in which the truth of the premises wouldn't necessitate that the conclusion is true. And I've shown that any argument like this form is not valid. Now, what they want to do in the textbook is introduce you to 4 valid argument forms in propositional logic and 2 fallacies that are invalid logical forms that people will often use mistakenly. So now I'm going to introduce you to these 6 total logical forms. First is modus ponens. Modus ponens is valid. Here's your structure for modus ponens. If P, then Q. That's a premise. P, therefore Q. Any argument this form is valid. So, for example, if it's raining, then the streets are wet. Well, it is raining, therefore the streets must be wet. If these first 2 premises are true, the conclusion's got to be true. That's modus ponens. Learn it, love it, live it. It's a great one. It's incredibly useful. I use it almost every day of my life, and I hope you do too. Now, it's easy to get modus ponens confused with an invalid argument form, which is a fallacy. The fallacy of affirming the consequent. Why do they call it affirming the consequent? Well, when you have a conditional statement, an if-then statement, the if statement, in this case P, is called the antecedent because it comes first. The Q, with the then statement, is called the consequent. So in the fallacy of affirming the consequent, you have a conditional statement, conditional premise, if P, then Q. And then the other premise is it affirms the consequent of the conditional, Q. And then here's the real mistake. It concludes that therefore the antecedent must be true, P. That's not the way modus ponens runs, but it looks close to it. So here's an example. If it's raining, then the streets are wet. Well, the streets are wet. Therefore, it must be raining. Does this look familiar? It is. It's the fallacy I just showed you a couple slides ago. Again, somebody could be hosing down the streets. The premises could all be true, and yet it's not necessarily true that it's raining. So that's a fallacy. Next is modus tollens, another good friend in the world of logic, which I encourage you to learn, love, live. Modus tollens starts out the same as modus ponens with a conditional statement, if P then Q. But then notice the other premise here. I want to say the second premise, honestly, it doesn't actually matter what order you put these premises in. It would still be valid. A note. But so anyway, the second premise is not Q. In other words, the consequent is false. And we can validly conclude from that therefore the antecedent is false, not P. So for example, if it's raining, the streets are wet. The streets are not wet though, so it must not be raining. That's valid. If those premises are true, they necessitate that conclusion. Again, there's an associated fallacy. Don't get modus tollens mixed up with the fallacy of denying the antecedent. So again, the fallacy starts fine with a conditional statement, if P then Q. But then it says not P, it denies the antecedent of the conditional. And it concludes fallaciously, therefore not Q. That doesn't follow though. Again, let's go back to our rainy streets. If it's raining, then the streets are wet. Well, it's not raining, so the streets must not be wet. Can you think of the counterexample though? Yeah, again, someone could be hosing the streets down. It could be true that if it's raining, the streets are wet, but that doesn't mean that's the only thing that gets the streets wet. Just because it's not raining doesn't mean they're not wet. Somebody could be hosing them down. So far, we have covered 2 valid argument forms and 2 invalid argument forms. We just got 2 more to go, and they're both valid and very useful. Next, that's nice. Hypothetical syllogism. Here's the form. If P, then Q. If Q, then R. Therefore, cut out the middleman. If P, then R. So here's an example. If you live in Greenville, then you live in South Carolina. If you live in South Carolina, then you live in the USA. Therefore, if you live in Greenville, you must live in the USA. That is valid. We got 3 simple statements and conjoined by in these conditionals in this fashion. So I'll let you just meditate on that and memorize it. And finally, disjunctive syllogism. A disjunction is an or statement. So there's 2 interchangeable forms that this can take. First of all, so the first premise here is P or Q. One of 2 things is true. Well, P is not true. So therefore, the other one must be true, Q. And again, you could have said virtually the same thing. P or Q is true, but you could say, well, Q is not true. Therefore, the other one must be true, P. So this is a disjunctive syllogism. It's like process of elimination. You got 2 possibilities, and you eliminate one of them, the other's got to be true. So for example, the bank robber was either a Bob Jones student or a Greenville Tech student. Well, it wasn't a Greenville Tech student, so who's left? It's got to be the Bob Jones student. Process of elimination. And this is what the form would look like. B or G, not G, therefore B. Now, there's an easy way to get confused about this, right? Here's like kind of an associated fallacy. Don't do this, all right? And the key is to distinguish between inclusive and exclusive disjunctions. You know, in natural language sentences, we often assume that disjunctions are exclusive. So if I say, well, you can have a piece of cake or you can have a piece of pie, you probably think, well, I've got to have one or the other. I can't have both. It's an exclusive disjunction. Choosing one option excludes the other. But actually in logic, unless it's otherwise specified, you should probably assume that disjunctions are inclusive. So if I say you can have cake or you can have pie, you could have both. They could both be true options. So this leads us, this is the key to the fallacy, right? So here's the fallacy. Premise 1, the bank robber was either a student at BJU or at Greenville Tech. Well, the bank robber was a Greenville Tech student. Therefore, the bank robber must not have been a BJU student. Now, this is a fallacy. You know why? Because the bank robber could have been duly enrolled at both institutions, right? The fallacy assumes that this disjunctive is exclusive, as if it's got to be one or the other and can't be both. But again, you got to assume that that disjunction could be inclusive, could be both. So this is not a valid argument form, B or G, G therefore not B. And that's different than the disjunctive syllogism, which said B or G, not G, therefore B. It's all about where the not goes. Okay. Here's another valid one though. Illegally downloading music and other files is morally wrong, unless there's an overriding moral reason to do so. Well, there's normally no overriding moral reason to illegally download music and other files. So therefore, illegally downloading music and other files is normally morally wrong. Now, this is a disjunctive syllogism. You might not notice it because there's no word or in there, but the logical force of the word unless is actually equivalent to or. Like there's two possibilities here. Either it's wrong or you're in an exceptional circumstance. Well, you're not in an exceptional circumstance, therefore it is wrong. Right? It's the exact same structure. So the word unless can function as an or. Now, why does all this matter? Because in your homework, you're going to be asked to identify the argument form of various arguments. Is this a modus ponens or modus tollens or disjunctive syllogism or is it a fallacy? So that's how these argument forms from propositional logic are going to be relevant to your work. Enjoy.